Welcome back to the EcoVantage Report. We're constantly told that the future is in the cloud. It sounds clean, weightless, invisible, but the reality behind artificial intelligence is anything but. Every AI model, every chatbot response, every generated image depends on vast physical infrastructure. Warehouses full of servers, cooling systems, power equipment, and an enormous amount of water. Some projections suggest that by 2027, global data centers could consume close to 5 billion cubic meters of water every year. The cloud isn't floating in the sky. It's rooted in the physical world, and its growing thirst is becoming impossible to ignore. To understand the problem, we need to understand the scale. AI-focused data centers can consume significantly more water than traditional cloud facilities because of their intense computing requirements. A single large data center may use millions of gallons of water per day for cooling. That's enough to rival the daily consumption of entire communities. Major technology companies collectively consume billions of gallons of water annually to keep their servers operating safely and efficiently. And much of that water never returns directly to the local system. In many facilities, cooling towers release water into the atmosphere through evaporation. The demand doesn't stop there. Before AI servers ever come online, semiconductor manufacturing requires enormous quantities of ultra-pure water to clean silicon wafers during chip production. From the fabrication plant to the data center, water has become one of the hidden resources powering the AI revolution. This isn't just an environmental story. It's becoming a geopolitical one. Many of the world's fastest-growing data center hubs are being built in regions already facing water stress, including parts of Arizona, Texas, and Chile. As AI infrastructure expands, local communities increasingly find themselves competing for the same resources. In Chile, concerns emerged after plans for large-scale data center development raised questions about long-term water availability in drought-prone regions. The debate highlights a growing global dilemma. How do societies balance technological growth with local resource security? And then there's another controversy. Many technology companies have pledged to become water positive by 2030, meaning they aim to replenish more water than they consume. Supporters view these commitments as an important step forward. Critics argue that replacing water in one region does not always solve shortages in another. On paper, the numbers may balance, but for communities facing local scarcity, the reality can be far more complicated. Perhaps the most uncomfortable part of this story is how closely it connects to everyday life. Researchers have estimated that training large AI models can require hundreds of thousands of liters of water, depending on the model, location, and cooling systems involved. Reports have also linked major AI training operations to noticeable increases in local water consumption near large data center clusters. And the impact doesn't end with training. Academic studies suggest that dozens of AI prompts may be associated with roughly half a liter of water consumption, although the exact amount varies depending on where and how the computation takes place. That doesn't mean every prompt directly uses up a bottle of drinking water. But it does reveal something important. Digital activity is not weightless. Every AI interaction depends on physical resources somewhere in the world. The AI revolution is reshaping our economy, our industries, and our daily lives. But every technological revolution comes with trade-offs. For decades, we've thought about data as something abstract and limitless. The rise of AI is forcing us to confront a different reality. Behind every prompt lies electricity. Behind every server lies infrastructure. And behind much of that infrastructure lies water. The challenge is not whether AI should exist. The challenge is whether we can build and operate these systems sustainably before resource pressures begin to catch up with technological ambition. The cloud may feel invisible, but its environmental footprint is very real. If you value the truth beyond the headlines, subscribe to the EcoVantage Report. Stay curious, stay informed, and we'll see you in the next deep dive.